It is Maar, the second video in POLYMATH shortcut video series. It's named as Maar. It depends on only three formulae. Number one, you can see that integral f of x whole power n into f dash x dx is equal to f of x whole power n plus 1 by n plus 1. Don't think that. It is a different formula. It is very much derived from integral of x power n dx, x power n plus 1 by n plus 1. How? Let f of x equal to t. Then f dash x dx is equal to dt. And thereby, it takes the form of integral of t power n dt. And it is nothing but t power n plus 1 by n plus 1. And the second one, replace n with minus 1 by 2. Replace n with minus 1 by 2. And thereby, it takes the form of integral of f dash x by root f x dx, which is nothing but 2 root f of x dx. Why we take it specifically? Because square root will get in the irrational functions, irrational integrals. And third one, integral f dash x by f of x dx, which is nothing but log mod f of x. Don't think that it is again different formula. No, it is nothing but integral 1 by x dx is equal to log mod fx plus c. By taking fx as t, we'll get f dash x dx as dt. So it takes the form of integral of dt by t log mod t dt. So we'll be working out the problems based on these three formulae: Maar 1, Maar 2, Maar 3. Let us see the problems, and you can, by using these three formulae, the substitution can be comfortably avoided. When the substitution is avoided in the indefinite integration, then it is easy for you to recognize the options. If you take it as t, and again you have to convert back that to x, and you have to search for the answer. But by applying these three formulae comfortably, getting the idea of applying these three formulae in the problems will be very much comfortable to you. Let us see the problems based on this today. Okay, now this is integral of x upon 1 plus x tan x, or it is, if you write tan x as sin x by cos x, it takes the form of integral x cos x by cos x plus x sin x. So if you see this is simply, if you observe the numerator, it is nothing but x cos x. If you observe the denominator, it is cos x plus x sin x. So it can be seen that cos x plus x sin x derivative is nothing but x cos x. You can check it out. Cos x plus x sin x. Don't again take it as t and simplify. See, cos x derivative minus sin x, and x sin x derivative sin x plus x cos x. So again x cos x remains. So it takes the Maar 3 integral f dash x by f of x ln mod of cos x plus x sin x plus c. It is done. The first one is done. It is depending on Maar 3. Let us see the next one. This is, if you see carefully, it is integral sin 2x divided by a square sin square x plus a square b square cos square x. Just see that carefully. Integral of sin 2x divided by a square sin square x plus b square cos square x. Just the observation is, what is the derivative of sin square x? It is 2 sin x cos x. What is the derivative of cos square x? Minus 2 sin x cos x. So the derivative of sin square x is sin 2x, and derivative of cos square x is minus sin 2x. So you can see that in the numerator. Whenever you come across this type of forms, never take it as t. Just to make the adjustment to get any one of Maar. Any one of Maar, it can be seen like this: integral of a square sin square x plus b square cos square x dash divided by a square sin square x plus b square cos square x dx. Just observe, you have to make a small adjustment of constant. Like what? It is nothing but a square sin 2x, and it is nothing but minus b square sin 2x. So what is that extra you get? by taking sine 2x common, you'll get an extra term 1 by a square minus b square extra. So this is again taking the form of tin mar 3 f dash x by f of x. So the final answer directly within one step we are writing 1 by a square minus b square ln mod of a square sine square x plus b square cos square x plus c. Next, integral of x root 1 plus x square dx. Generally, whenever you come across the indefinite integration, you always think of taking some function as t and then integrating it. Never do that whenever the problem takes the form of tin mar. Let us see this now. If you take integral of, how to get the idea, if you take integral of x root 1 plus x square, under root there is 1 plus x square. What is the derivative of 1 plus x square? 2x. 2x, x is outside. So it is simply 1 plus x square whole power 1 by 2 into 1 plus x square dash dx. So what is 1 plus x square derivative? 2x, but 2 extra. So divided with 1 by 2. And it is taking tin mar 1 fx power n into f dash x. So it is nothing but fx power n plus 1 by n plus 1 plus c. Done. Okay, next. Integral of, see that one, integral of root over 2 plus sine 3x into cos x. So, just see root over 2 plus sine 3x whole power, that is, it can be written as 2 plus sine 3x whole power 1 by 2 into 2 plus sine 3x dash. How do you get the idea? Because sine 3x derivative 3 cos 3x. 3 cos 3x, but you have only cos 3x there. You'll get 3 cos 3x here, right? 1 by 3 out. So it is 1 by 3. It is tin mar 1 again. 2 plus sine 3x whole power 3 by 2 into 2 by 3 plus c. That's it. Coming to the next one. This is integral of root tan x. It's a very familiar problem only for you, but generally you think of substitution method always, and you are habituated to substitution. But when you think of this tin mar, all these problems can be solved within 1 or 2 steps like this. Now I want this in the form of tan x. So root tan x divided by, what I'm doing, I'm dividing this sin x with cos x, and this becomes cos square x dx. I want to apply any one of tin mar here. So this is integral of root tan x by tan x, which becomes tan x whole power minus 1 by 2, bring it to the numerator. Tan x whole power minus 1 by 2, bring it to the numerator. Secant square x. So this is tan x dash dx, which is nothing but tin mar 1 fx power n into f dash x. So fx power n into f dash x, or you can see this also as f dash x by root fx. Tin mar 2 please. Tin mar 2 f dash x by root fx. Let me write like that so that you will understand how that will be used. This is integral of secant square x divided by root tan x dx. Just to see tin mar 2 there. F dash x by root fx is nothing but 2 root fx plus c. So see how that tin mar 2 applied. Go to the next one. This is, from this problem onwards, I have taken all the latest previous questions, to make you understand the easiness of this indefinite integration using this tin mar formula. Now, if you see that problem, you may be feeling that it is a violent problem. See how simple it is, how simple it is. This is integral of. What I'm doing in the first part, I'm taking up x common, x into x power 3m minus 1 plus, and second term x power 2m minus 1, and third term x power m minus 1 into what is the term, second bracket there, 2 into x power 2m plus 3x power m plus 6 whole power 1 by m is there. Just see that. Whole power 1 by m is there. Now what I'm doing, I have taken x common here. I'm sending this x inside this bracket. I'm sending this x inside this bracket. To send this x inside the bracket, because you have whole power 1 by m there, when it enters inside the bracket, it becomes x power m. Why? X power m whole power 1 by m. Again, mm gets cancelled, x only comes out. So, what I'm doing, now I'm writing it as x power 3m minus 1 plus x power 2m minus 1 plus x power m minus 1 into, send this x inside that brackets as x power m. Then what happens? It becomes 2x power 3m plus 3x power 2m plus 6x power m whole power 1 by m dx. Just observe it, how it takes the form of T Maar. What is the derivative of this? X power 3m derivative, 3m into x power 3m minus 1. This is 2 into 3m, 6m. Again, what is its derivative? 2m into 3, 6m into x power 2m minus 1. Its derivative, 6m into x power m minus 1. So, if you see, 6m is common here. By taking 6m common, you will get the same term. By taking 6m common, you will get the same term. So, what is that I'm doing? Integral of. I'm writing it like this. 2x power 3m plus 3x power 2m plus 6x power m whole power 1 by m into 2x power 3m plus 3x power 2m plus 6x power m dash. Just check it out, please. Just check it out. So you will get 6m extra here. That's what I explained in the previous step. You will get 6m extra here. Write that 1 by 6m here, or for the better understanding, write by 6m here, because if you divide with 6m, if 6m divides this, then you will get the same term. So this term is written as f dash x now. This term is written as f dash x now. So what is that you get now? What is that you get now? What is the form you are getting now? It is 3 Maar 1 fx power n into f dash x. Fx power n into f dash x. So it is 1 by 6m into 2x power 3m plus 3x power 2m plus 6x power m whole power m plus 1 by m. That is fx power n into f dash x dx, fx power n plus 1, that is 1 by m plus 1, n plus 1 by n plus 1, that is m plus 1 by m. After that, you can check the answer. Only thing is, you have to get the idea first. You have to get the idea of any one of these T Maar. So, it is done. Let us go to the next one. What I said, what I said, I have collected all these questions very much from the latest previous question papers. Just to explain you how these three formulae that can be comfortably used to avoid the substitution in indefinite integration. If you see the next one, integral of x cubed divided by 1 plus x power 6 whole power 2 by 3. X power 6 whole power 2 by 3. How to get the idea first? See, you have x cube outside the bracket and inside the bracket x power 6 whole power 2 by 3 is there. For example, if I take x power 6 common, what is the power 2 by 3? So, if I take x power 6 common within the brackets, the term which comes out of the bracket is x power 6 whole power 2 by 3. X power 6 whole power 2 by 3. So, that goes for 2 times and you will get x power 4 common. X power 4 common. So that x power 4 into x cube becomes x power 7. X power 7. So you think in this direction. What is integral of x power minus 7? What is integral of x power minus 7? X power minus 7 plus 1 by minus 7 plus 1. That is x power minus 6, which is nothing but 1 by x power 6. 1 by x power 6. If you have that term within the brackets, it is done. It takes 3 Maar 1. It takes 3 Maar 1 fx power n into f dash x. Let us show it out. Let us show it out. This is equal to, what is that I said? I am taking out this x power 3 is already there. I am taking up x power 6 common and thereby I'll get x power 6 whole power 3 by 2 whole power 2 by 3. X power 6 whole power 2 by 3 into 1 plus x power 6. I have taken x power 6 common and thereby it becomes 1 by x power 6 plus 1 whole power 2 by 3. Just to see that. What is the alteration I did and how do we see this? We are just trying to get it to the form of any one of 3 Maar. It is possible whenever you are able to write f dash x of the given function, it is done. Take it as granted that it takes any one of 3 Maar, one of the 3 Maar formula. So this is integral of, just to see this, dx divided by, see, this goes for 2 times x power 4 into x cube becomes x power 7 and it is 1 by x power 6 plus 1 whole power 2 by 3. Now just check it out. It is 1 by x power 6 plus 1 whole power minus 2 by 3 into 1 by x power 6 plus 1 dash dx. Just see that. If I write like that, how do we get the idea? Its derivative is nothing but minus 6 by x power 7. See this. X power 7 is there. 1 by x power 7 is there. So minus 6 extra. So write minus 1 by 6. Because you get minus 6 extra there. Minus 6 extra. It's a constant. I wrote it outside. No problem. Now it will be simplified like this. Minus 1 by 6. 3 Maar 1. Fx power n into f dash x dx. So fx power n plus 1 minus 2 by 3 plus 1, I am writing directly. 1 by 3 into 3 plus c. This goes for 2 times. That's all done. The problem is solved. See the easiness of the problem when you are applying this 3 Maar formulae. And generally you think of always applying substitution. So avoid substitution as far as possible. I don't say that all the problems can be solved without substitution. No. Many problems are there that can be solved without substitution using this 3 Maar formula. Let us go to the next one. So next one is x plus 1 divided by root over 2x minus 1. This is also latest previous question. You can check these questions in your latest previous papers. So this one, integral of x plus 1 divided by root over 2x minus 1 is equal to f of x into root 2x minus 1 plus c, then find f of x. Means he solved the problem, he gave the integral of it and he took some part of it as fx. So it is integral of x plus 1 divided by root over 2x minus 1 dx. Let us solve it as if we don't know the solution. We don't know the solution. So here, if you write this, what happens? It is integral of, what I'm doing now, I want to convert this, I want to make use of this Maar formula. So that is the reason why I'm creating 2x minus 1 forcibly in the numerator. So what is that I'm doing? 2x minus 1 I wrote, but I wrote 1 by 2 because I have only x there. Only x there. 2 to getting cancelled, x only remains. So what is the extra term I wrote? Minus 1 by 2 I wrote extra. So plus 1 by 2. Already plus 1 is there. Wrote it divided by root over 2x minus 1 dx. Just to say this now. This is, if you split it, it is 1 by 2 integral of root 2x minus 1 dx plus 3 by 2 into, just again, no confusion, it is Maar 2, if you say Maar 2, f dash x by root of x. F dash x by root of x. This is root of x, let me say. What is its derivative? 2. It's not there. 2 is not there. But I am writing forcibly 2 divided by root over 2x minus 1 dx. And because I wrote 2 extra, I am writing 1 by 2 there. Just to see that. Just to see that what I did. I applied Maar 2 here. F dash x by root of x. You can straight away write it as 2 root of x. And this one, anyway, it takes the form of x power n. So, what is the integral of x power n? X power n plus 1 by n plus 1 plus, this is 3 by 4 into 2 root of x, I said. Maar 2, please. Maar 2. 2 root 2x minus 1 plus c. Just see that. Now, if you simplify this, but that problem, we don't need the answer there because he modified this and he gave some function there, f of x. So you have to get it to that form. So what is that I'm doing? I'm taking up this 2 to getting cancelled here, and 3 into, this can be written as 3 into 2x minus 1 into root 2x minus 1 plus 3 by 2 root 2x minus 1 plus c. Now if you take root 2x minus 1 common, within the brackets you are getting, this is 1 by 3, and you have one more 2 also here because 2x minus 1 derivative is to be divided, one more 2 is also there. So you'll get, if you take root 2x minus 1, you'll get 6 here. 1 by 6 here. You get 1 by 6 here. So this is, if you take root 2x minus 1 common, 2x minus 1 by 6 plus, here you have 3 by 2. Plus c, of course, there. And now it is root 2x minus 1 into 6 LCM there, and you will get 2x minus 1 plus 9, which is nothing but 2x minus 1 plus 9, 2x minus 8 by 6 plus c. So your fx is this. Just see. Check the options. You have these previous questions. So your fx is nothing but x minus 4 by 3. So see, we have applied Maar 1 here. We have applied, this is direct formula, not Maar 1, it is x power n, standard anti-differentiation formula. Here we applied integral f dash x by root of x, which is Maar 2. Like this, it goes. Let's read the next one now. If you see the next question is root over 1 minus x square by x power 4. This is also an interesting question. Generally, the students get confused by seeing this type of problems, but most of these problems are solved by using this Maar. So, integral of, it is also simplified as a of x into root over 1 plus x square whole power n plus c. So, integral of root over 1 minus x square by x power 4. What I'm doing, I'm just giving you the idea how to get getting the idea is very important. Converting the definite integral to the standard form is very, very important here. So if you see that now, integral root over 1 minus x square. The numerator is containing root over 1 minus x square. If I take x square common under the root, x comes out. When x comes out, the denominator is x power 4. Then numerator x, denominator x power 4. So 1 by x cube remains. 1 by x cube remains. You have to think like this. What is integral of 1 by x cube? What is integral of 1 by x cube? X power minus 3 plus 1 by minus 3 plus 1. Which is nothing but, if you take only variable, 1 by x square. 1 by x square. So derivative of 1 by x square will give you that. So in that way you have to think. So whether you have 1 by x square in the given function or not, yes, because we have taken x square common in the numerator, you will get 1 by x square inside the root. So it takes the form 3 bar 1. So let us see that. Integral of. Let me take x square common in the root. So this becomes 1 by x square minus 1 divided by x power 4 dx. Just see that. So what happens? Integral of, you are getting 1 by x here when you take x square out of the root. So this becomes 1 by x square minus 1 whole power 1 by 2. And it is 1 by x cube, please don't forget. That is adjustment we have to do. 1 by x square minus 1 dash. If I write like that. 1 by x square minus 1 dash. What is the derivative of this? 0, of course. One derivative is 0. 1 by x square derivative is x power minus 2 derivative. Minus 2 into x power minus 3. That is minus 2 by x cube. Minus 2 by x cube. So extra minus 2 you are getting. So write minus 1 by 2 dx. So what is that you get here? Minus 1 by 2 into 1 by x square minus 1. Just see that. 3 bar 1, fx power n into f dash x. Fx power n into f dash x is nothing but fx power n plus 1 by n plus 1. Okay. Into minus 1 by 2, I wrote it already. So 2 to getting cancelled here. 2 to getting cancelled here. What is that you get? Minus 1 by 3. I'm getting this here. Take LCM there. 1 minus x square by x cube you will get. That is x square LCM, x square whole power 3 by 2. 2 to getting cancelled. X cube remains. And it is whole power 3 by 2. Let us see how he adjusted it. He is writing it as root over 1 minus x square whole power m. So this is minus 1 by 3x cube into root over 1 minus x square whole cube. Just check it out. This whole power 1 by 2 I wrote it as under root whole cube. Plus c. What is the question there? He is asking for a of x whole power m. This is nothing but a of x, please. This is nothing but a of x. So a of x whole power m is equal to minus 1 by 3x cube whole cube is nothing but minus 1 by 27 x power 9. Just see that. Minus 1 by 27 x power 9. See, here, what is the formula we applied? Again, we applied 3 bar 1 there, fx power n into f dash x. You have to understand that adjustment, that's it. So try to avoid substitution so that the time will be saved. Time will be saved. If you substitute now, what happens if you substitute it as some t and finally your answer is in terms of t and again you have to get back to x to check the answer. You can avoid all this by simply applying this theme Maar. Coming to the next one. Next one is, all these are latest 2019 GE main previous questions. See, integral of sine nth theta minus sine theta whole power 1 by n divided by sine n plus 1th theta. See, I want to give you the idea first. How to get the idea is very important. How to get the idea to apply any one of these 10 mark. See, denominator is containing sine theta whole power n plus 1. And the numerator is containing sine nth theta minus sine theta whole power 1 by n. If I take sine nth theta common in the numerator, then sine nth theta whole power 1 by n comes out. Then you will get sine theta out. When sine theta is out, the denominator becomes sine nth theta. Then you can adjust it. Let us check it out. Integral of. I am taking out sine nth theta common. If I take sine nth theta common, because whole power n is there, whole power 1 by n is there, that also comes out. So what is that remaining in the brackets? Into 1 minus. The second term is sine theta. Sine theta divided by sine nth theta, which becomes sine of 1 minus nth theta divided by sine n plus 1th theta. Check it out, please. Check it out what I wrote. Okay, so now the numerator becomes sine theta. Denominator is sine n plus 1th theta. That sine theta comes down. This becomes integral sine nth theta. And the numerator becomes, this is already done, 1 minus sine of 1 minus n theta. Whole power 1 by n is there. Just see that. Now what I'm doing, I'm just trying whether it can be converted to thin Maar 1 or not. So let me try that. 1 minus sine 1 minus n theta whole power 1 by n into 1 minus sine 1 minus n theta dash. Let me write that. So what happens? This is 0. What is sine 1 minus n theta derivative? 1 minus n into sine theta whole power 1 minus n minus 1. Array x power n derivative n into x power n minus 1. If you apply that, you will get the same. And you have cos theta also there. Cos theta. I think there is a printing error there. You have cos theta must also be there. Check the original question. You have cos theta. Because I only typed this, I remember you must have cos theta there. So this becomes now just check it out. This becomes now sine theta whole power minus n. This term you'll get sine theta whole power minus n into cos theta. What is it? Its derivative I'm talking about. One derivative is 0 and its derivative is sine 1 minus nth theta derivative 1 minus n into sine theta whole power 1 minus n minus 1 getting cancelled. You will get sine theta whole power minus 1 into sine theta derivative cos theta. Just to say this. Sine theta whole power minus n into cos theta. So it is taking the form of what is the term extra you will get divided by, let me write, 1 minus n minus of 1 minus n extra you will get. So this becomes 1 by n minus 1. Just in Maar 1, fx power n into f dash x. Fx power n into f dash x. This you need not have to write because that cos theta goes inside the derivative. So here you must write, but that cos theta goes inside the derivative. So now this is nothing but 1 minus sine 1 minus n to theta whole power 1 by n plus 1, that is n plus 1 by n into n by n plus 1 plus c. Yes, you see that. This becomes n by n square minus 1. N by n square minus 1 into this one. So it is using 3 Maar 1 please, integral of x power n into f dash x. Only thing is that adjustment you have to understand. There are many such problems. I cannot discuss all the problems, or that is why I have taken the previous question just to make you understand how this 3 Maar is applied here. But of course, this problem, what the next problem is, this is direct problem only, without these 3 formulae, with adjustment of trigonometric adjustment. And trigonometric formula is needed to solve this problem. But getting the idea for this one also little difficult. So sine 5x by 2 divided by sine x by 2 is there. The idea is we want to split it to the standard format. Anyway, it is to be converted to the standard format. That is the reason why what I'm doing, I'm multiplying the numerator with cos x by 2 and denominator also with cos x by 2 and 2 by 2. That means I am multiplying with 2 cos x by 2 and dividing with 2 cos x by 2. And thereby the numerator becomes 2 sin a cos b, trigonometry formula. You have to have the knowledge of, or you have to remember the trigonometry formula, because many problems in integration or to be solved using the trigonometry formula. 2 sin a cos b, 2 sin a cos b, sine of a plus b plus sine of a minus b whole divided by sine 2x plus. This is 2 sin a cos a, sine 2a becomes sine x dx. Now by now you must have understood sine 3x contains sine x as common term. Sine 3x contains sine x as common term. What is the formula for sine 3x? 3 sine x minus 4 sine cube x. So you can take sine x common there. If you take sine x common, within the brackets you will get 3 minus 4 sine square x. Here sine 2x, 2 sine x cos x. Again sine x common, 2 cos x remains. You can take sine x common in the numerator. You can get it cancelled. So thereby what happens? You will get it as, directly I am writing 3 minus 4 sine square x plus 2 cos x. After cancelling sine x both in the numerator and denominator, you will get this. So integral of 3 dx, 3x plus 2 cos x minus 2 sine x. I wrote this directly. And this one, 4 sine square x integral. This is what the difficulty in integration. If it is a derivative, if I ask you what is the derivative of sine square x, everyone immediately says 2 sine x cos x. But in integration, integral of 4 sine square x cannot be directly said, because we don't have any chain rule or function of a function rule like we have in differentiation. That is the reason why, unless it is reduced to the standard format, you cannot integrate it. That is the reason why you have to write it like this: minus twice integral of 1 minus cos 2x dx. Just see that. This is 3x minus 2 sin x minus 2 integral of 1x minus cos 2x integral sin 2x by 2 plus c. This is done. Here we have not used the 3 Maar formula. Just I want to make you to other track I have taken this problem. It is sine of 5x by 2 by sine x by 2. It is purely trigonometric simplification, and the reduction here, this without the reduction you cannot solve this problem. Let us see the next problem. It is also latest previous question. What is it? Just observe. It is integral of 3x power 13 plus 2x power 11 divided by 2x power 4 plus 3x square plus 1 whole power 4. If you see the denominator, is there any relation to make it to the Maar form? Yes, you can. How Let us take x power 4 common in the denominator. Just listen and have mind calculation first. That is very important. Have mind calculation. If you take x power 4 common, you will get x power 16 out. X power 16 out in the denominator. Then you send that x power 16 in the denominator to the numerator. Then what happens? You will get x power 13 by x power 16, x power 1 by x power 3 you will get. Similarly, 3 by x power 3, I am not taking that constant there. I am seeing only the variable there. X power 11 divided by x power 16, which becomes 2 by x power 5. So, if you see the integral of 1 by x power 3, if you see the integral of 1 by x power, whatever the numerator is there, if you see its integral, you will have the same term in the denominator. You will have the same term in the denominator. That is why the derivative of the denominator becomes the numerator. You have to see that. We will have some more such problems in the later videos. See, this one what I am saying, it is integral of, what is I am doing? I am taking up x power 4 common within the brackets of the denominator, and thereby I will get x power 4 whole power 4 common. What is that there in the brackets now? 2x power 4. Because x power 4 taken common, you will have only 2 plus 3x square by x power 4, you will get 3 by x square. And plus 1 by x power 4. Whole power 4. Just to see that. Write the numerator as it is. 3x power 13 plus 2x power 11 dx. Now, let me divide this. Let me send the denominator through numerator. X power 13 by x power 16. What is that you get? X power 3. 3 by x power 3. Here you will get 2 by x power 11 by x power 16, x power 5 divided by 2 plus 3 by x square plus 1 by x power 4 whole power 4 dx. See, we are avoiding that substitution totally, and we are making use of this Maar formulae. Don't forget that. Don't forget that. Now, if you see this, integral of 2 plus 3 by x square plus 1 by x power 4 whole power 4 brought to the numerator becomes whole power minus 4 into 2 plus 3 by x square plus 1 by x power 4 dash. Let me write and check first. Let me write. How do I get the idea, When you have 1 by x square here, you have x cube there, 1 by x cube. That means the derivative of the 1 by x square, derivative of 1 by x square becomes 1 by x cube form. And this is 1 by x power 4. Relation between integration and differentiation. Anti-differentiation is nothing but integration. So that's what the property we are using. Derivative of 2, 0. Derivative of 3 by x power 2. What is it? X power minus 2 derivative. X power minus 2 derivative is nothing but minus 2 by x cube. Minus 2 by x cube. What is that? We have 3 by x cube only. So you have got extra term here. Minus 2. Let us see. What is that adjustment to be done? Here it is x power minus 4. Minus 4 by x power 5. Minus 4 by x power 5. This is minus 6 by x power 5. So you can take minus 2 here, minus 2 common there. So you'll get minus 2 extra there. So we are dividing with minus 2. Check it out, please. Check it out. That idea you must get. That idea you must get. See, repeating x power minus 2 derivative, minus 2 by x cubed. 3 is there already, so minus 2 extra. X power minus 4 derivative, minus 4 by x power 5. Minus 4 by x power 5, but you have only 2 there, so minus 2 extra. Here also minus 2 extra. So that is why divided with minus 2. It is done now. 3 mark 1 fx power n into f dash x dx. Fx power n plus 1 by n plus 1. So here the final result will be 2 plus 3 by x square plus 1 by x power 4 whole power minus 4 plus 3 minus 4 plus 1 minus 3 divided by minus 3 into minus 2. Just check for the options now. In the options, there may be, it may be simplified like this by taking x power 4 as LCM. That's all the difference. That's all the difference. So what is the formula we use here? Fx power n into f dash x. Only thing is we have to convert it to that form. So that is the difficulty in integration. What is the difficulty? Converting the given function to the form of the standard formula. Once if it is converted to the standard formula form, take it as granted the problem is solved. In differentiation, there is no such problem. In differentiation, whatever the function is given, we will consider the given function in the form of the formula and we differentiate it because of function of a function rule or chain rule. Okay, that's all for this session. In the next session, video number 3, we'll be doing the problems that are taken in the first session, which is top decoration, and in this session, Maar, using these two, how the problems can be solved. So in the next video, we are top decorate to Maar. Top decorate to Maar. That is the next session. Namaste. We'll see you in the next video.